the data and linear regression model, which we take in phase 1 and phase 2 between Tesla Inc., S&P 500, and DOW Jones. Before going into the details, I would like to introduce my group project partner, Surya Prakash Tamoli, Royston Joy Arhana, Sanal John, Dilvi Maria Davis, and Saiti Bolipalli. So, while talking about the agenda of our project, first we are going to introduce what our project is about and the methodology and the results we get while calculating the data between the closing stock price data between Tesla Inc., S&P 500, and DOW Jones, and the different data analysis method and the findings. And at last, we will give the recommendation and provide the conclusion. The introduction of project. The project focus on the analysis and the prediction of stock price fluctuation based on historical data, with particular focus on Tesla Inc., the S&P 500, and the DOW Jones. This project used advanced method of forecasting to give beneficial insight about future market trends and improve decision-making process. The project starts with the in-depth examination of historical data using time forecasting, linear regression model, and correlation analysis. We use evaluation metrics to check the data accuracy, whether the data is accurate or not, to predict in the future and the market trends. Prediction reliability and accuracy have been evaluated using important accuracy measures such as mean absolute deviation, mean square error, and the mean absolute percentage error. Beyond correlation, the research investigate statistical significance, differentiating important implication for decision making from random chance of relationship. The linear regression model is used to forecast future stock price values for Tesla Inc., the S&P 500, and the DOW Jones over 3 month of time frame. The initiative provides a one of a kind of combination of accurate forecasting, in-depth correlation research, and through accuracy evaluation, allowing decision makers to confidently go through the complicated world of finance. So, while talking about the methodology and results, we use linear regression model to forecast the data by using the historical data of Tesla Inc., S&P 500, and DOW Jones. We forecast the 3 months data for the selected company and the indexes. We use evaluation metrics such as MAD, MAC, or MAPE to check the accuracy of the data, and at last we calculate the correlation and coefficient between the data of Tesla Inc., S&P 100, and DOW Jones by using regression analysis. So for next part, I would like to hand over to explain the forecast results and forecast accuracy to my colleague Saiti Bolipalli.
Hi all, I'm Sahiti. So today I'm going to discuss about the forecast analysis and accuracy of three different indexes such as Tesla Incorporation, S&P 500, and Dow Jones as well. So this slide shows us the forecast result of Tesla Incorporation. So we can see the closing stock price that is represented by the blue line of Tesla Incorporation from the year November 2022 to October 2023, and also we will be calculating the forecast results based on the linear regression model. So in this slide we can see that the Tesla closing stock price has started from 195 in the year in the month of November 2022, and it has been decreased in the month of December, and it has raised constantly, and it shows a decrease in the month of April, and it has increased till June, and it has decreased in the month of September. And the orange line shows the forecasted value of Tesla Incorporation for the 3 months, that is November, December, and January. So we can see the fluctuations in the stock price of this Tesla Corporation. So this may be due to the demand and supply of Tesla products and services, such as electrical vehicles, batteries, solar panels, and software as well. The closing stock price can also vary based upon the competition. Like nowadays, Tesla is facing many competition from both traditional automakers and new entrants as well. So coming to the next slide. So this slide represents the forecast analysis of S&P 500. It has started at 4,080 in the month of November, and it has decreased in the month of December and raised in the month of January. And we can see a slight fluctuations till the month of May, and it has rised in the month of July, and it has decreased in the till the month of October. So we can see the fluctuations of S&P 500. So this may be due to the inflation, like the surge of inflation led to the rise of interest rates several times. So that has reduced the demand for stocks and bonds of S&P 500. And here the orange line shows the forecast values of S&P 500 in the upcoming 3 months, November, December, January, based on the linear regression models. So coming to the next slide. So this shows us the forecast of Dow Jones. It has started at 34,589 in the month of November, and we can see the highs and lows, and we can see a peak in the month of July, and it has decreased in the month of October. So we can see these fluctuations in the stock market, which are influenced by many factors such as economy, earnings, sentiment, geopolitics, and many other events. And here the forecast value is in a standard mode that is calculated based on the linear regression model. We can see the forecasted value is seen in the month of October, November, and December as well. So this shows the forecast accuracy of the three companies, Tesla Incorporation, S&P 500, and Dow Jones. And here the MAP stands for mean absolute percentage error. It is the average of the absolute values of the percentage errors between the actual values and the predicted values as well. And the MAC stands for mean squared error. It is the average value of the squared errors between the actual and predicted values. MAPE stands for the mean absolute error, and it is the average of the absolute errors between the actual and predicted values. So in this table, we can see the comparison. So this comparison shows that the linear regression model is more accurate for S&P 500 than Dow Jones or Tesla. So the S&P 500 mean absolute error is less than 1%, which means that the forecasted values are very close to the actual values. The Dow Jones mean absolute error is about 6%, which means that the forecasted values are somewhat lower than the actual values. The Tesla Incorporation mean absolute value is about 13%, which means that the forecasted values are significantly higher than the actual values. So the accuracy of linear regression model depends on how well a model fits into the data and how stable the data is over time. So the S&P 500 data seems to have a strong linear trend and low variability, which makes a linear regression model a good fit. So now my teammate Dilvi is going to explain you about the correlation analysis. Yeah.
Thank you, Sahiti. My name is Dilvi Maria. I am here to explain the correlation analysis between based on the monthly return. Let's see the correlation coefficient calculation of Tesla with S&P 500 and Dow Jones. Mainly, a correlation analysis examines how two sets of data move in relation to each other. Here, correlation is calculated using the data analysis itself with the help of Excel by pairing Tesla's monthly return with S&P 500 and Dow Jones monthly return. In the first case, let's compare the Tesla with S&P 500. Here we can see that the R-square value is near to 1, which is about 0.42. And the dependency percentage is about 42.44%, which clearly shows that it is dependent of one another. And in the second case, while we consider Tesla with the Dow Jones, the R-square is about 0.09, which is far less than the value 1. And so we can say that there is no significant dependency in the case of Dow Jones and Tesla. Therefore, this analysis shows that there is comparatively less correlation between these two companies. And this type of analysis is mainly help investors to understand how Tesla stock behave compared to these two big indexes. Now, I welcome Royston to explain the next part, the statistical significance of correlation.
Hi, my name is Royston Joy Arana, and today I will speak about statistical significance of correlation between Tesla and the two indexes, that is Dow Jones and S&P 500. So we did a thorough analysis on the statistical significance of Tesla and our two indexes. After doing a thorough analysis, we observed the following data. In terms of the comparison between Tesla and S&P 500, the coefficient value is 0.65, and the coefficient determination, that is the squared R, is 0.42. Whereas the comparison of Tesla and Dow Jones, the correlation value is 0.31, and the coefficient of determination squared R value is 0.097. Based on the following research, we've identified the dependency value of both the companies, X and Y. The dependency value of S&P 500 and Tesla is 42.44%, and the dependency value of Dow Jones and Tesla is 9.78%. After doing a thorough research, this is what we've identified. That is, there is a partial level of dependence between S&P 500 and Tesla. We got some interesting insights from the comparisons between Tesla and two of our indexes. Now I will explain whether the following information is statistically correlated between two of our indexes. So I did a hypothesis testing using data analysis. Using data analysis, we came to a conclusion that it is positively correlated. I would like to illustrate by giving some more information. The correlation coefficient gives us an indication and direction of the linear relationship between two of our variables. So the first hypothesis testing that we did was null hypothesis, wherein we compared S&P 500 with Tesla. The very first information that we got to know was with a correlation coefficient of 0.65 and a reasonable high coefficient of and determination, there is a significant positive correlation between S&P 500 and Tesla. This is what we've identified after doing a hypothesis testing on Tesla and S&P 500. Secondly, we did hypothesis testing between Tesla and Dow Jones. The correlation coefficient value of 0.31 indicates a positive relationship, and therefore it suggests that there is still a statistically significant relationship. In summary, based on the following data using hypothesis testing, we've identified that there is a statistically significant positive relationship between Tesla and two of our indexes, that is S&P 500 and Dow Jones. However, the strength of the correlation varies, with S&P 500 showing a stronger correlation than Dow Jones. Now, my friend Sanal will talk about the conclusion part.
Hi, hi. My name is Sanal John. I am here to explain the conclusion. In predicting Tesla stock price movements, the forecasting model demonstrates moderate accuracy. When examining the correlation analysis, there are positive relationships between Tesla and both S&P 500 and Dow Jones. The findings are statistically significant, indicating that one moves, the others tend to follow. Notably, the correlation is stronger with S&P 500, suggesting a more pronounced connection between Tesla stock performance and broader market represented by S&P 500. Additionally, the model exhibits higher precision in forecasting the S&P 500 and remarkable accuracy in predicting Dow Jones movements. I am inviting Surya to give some recommendations.
Thank you, Sanal. Hi everyone. My name is Surya. I will explain the recommendation part of this project. So As you already know, recommendations are essential as they provide a structured approach to the modeling process, addressing common challenges and ensuring that the resulting models are not only statistically sound, but also practically used for making predictions and informed decisions. So talking about a time series recommendation, as we can see, data processing, feature engineering, stationarity, model selection, and hyperparameter tunings. In data processing, it carefully handle missing values, outliers, and ensure a consistent time interval between data points. And feature engineering, it extracts relevant features such as lag values, moving averages, and other time-related features to capture important patterns in the time series data. Talking about stationarity, it ensures stationarity of time series by applying transformations or differentiation. Stationary time series often yield more reliable predictions. Talking about model selections in the recommendation, it experiment with different time series models such as ARIMA, SARIMA, or PROFIT to identify the model that best fits the data. Consider seasonality and the trend components in the Bayesian model. So the final recommendation for time series will be hyper parameter tuning. Here, it fine-tune the parameters of the selected time series model to optimize its performance. This may involve adjusting lag values, seasonality period, and other model-specific parameters. And talking about linear regression recommendation, the first one will be feature selection. It identify and select relevant features that have a significant impact on the dependent variable. It use techniques like features importance or backward elimination to streamline the model. Next recommendation will be multicollinearity. It check for multicollinearity among independent variables. High correlation between predictors can affect the stability and interpredictability of coefficients. The next one will be residual analysis. It examines the residual to ensure that the assumption of linear regression are met. So the next recommendation our project will give will be the cross validation. It implement cross validation techniques such as k-fold cross validation to assess the model generalization performances on different subsets of data. The final recommendation for linear regression will be regularization. It will consider using regularization techniques like ridge or lasso regression to prevent overfitting and improve model generalization. These methods can help control the complexity of the model. Thank you so much. Here ends my part. And thank you so much, everyone, for participating in this project. Thanks.
Thank you.
Thank you.
Thank you.